So getting started in part 1, install the beautiful soup in Ubuntu by using the apt-get command. And again, you can do this by copying and pasting in the lesson 3 stage 2. In part 2, modify your tweet spout to admit only the first URL contained in a tweet. We do that in lesson 2 stage 2, navigate to the tweet spout. We see that in the tweet spout, the current logic states that a status.getText is how we're getting our tweet messages. First, comment out the queue.offer, and using the syntax hint, we create a string URL. We check that the status.getURL entities.length is not equal to 0. If length is not equal to 0, we assign the URL using the getURL function in the hint. And finally, using the same syntax, we add the URL in the queue. Scrolling down in the tweet spout logic, we see the next tuple method will pull from the queue, check that the queue is not null, and if not, it emits a string using the collector.emit function. Finally, in the declare output fields method, you can leave the field as tweet. Next, it's time to create your Python file in part 3. Create a new Python file in the resources folder url text.py. So in Atom, it's add file url text.py. And again, remember that it's a Python file that goes in the resources directory. In part 4, we define the main functionality to use urllib2 and beautiful soup from PS4 to define a new class urlbolt to open and receive URLs, parse, and emit text. I use the splitSentence.py example from stage 1. Using splitSentenceBolt as an example, we create the urlbolt class. First, we get the URL coming from the tuple.values at 0. Next, in the urllib2 library, we get the HTML file using urllib2.urlopenurl.read. Finally, from the syntax hints, using beautiful soup making the soup, we have soup equals beautiful soup that takes in the HTML we defined. Next, using the syntax hints again, we use the soup.findAll method that searches for title and paragraph tags. And finally, we check if the URL text is not null. In Python, this is falsy, so if URL text is length 0, this will be false. But if it's true, we form a list comprehension. This is why I kept the storm.emit word syntax here, but we can now get rid of this. And using the storm.emit syntax, we emit t.string for t in URL text. Finally, again in the hints, we want to wrap this in a try except pass statement because any 404 error will crash Storm. Once we wrap the try except pass, we update our urlbolt class. And now we have our urlbolt class.run statement. And finally, we include our import statements urllib2 and from BS4 import beautiful soup. Finally, in part 5, create a Java bolt urlbolt.java, and remember this is located in the Storm folder and not the resources folder. Once created, again keeping the import statements the same, we can copy the splitSentence.java file into our urlbolt.java file. Next, we update the class to urlbolt, update the constructor from splitSentence to urlbolt, update splitSentence.py to urltext.py, and finally, I declared my new field text instead of word. Note again that the Python bolt urltext.py does not declare an output field, and this must be declared in the urlbolt.java. The URL bolt will be connected to our Python parse bolt using a shuffle grouping. Therefore, the field we choose will not be used in a field grouping, but we will call this text. Finally, in part 6, we update the topology by navigating to the tweet topology. We add the URL bolt with a component ID python-url-bolt. And here we have a shuffle grouping connecting the tweet spout. And finally, to complete the topology, we see that the tweet spout connection to the Python split sentence bolt needs to be updated to the Python URL bolt. And one final check on our topology, we have the tweet spout, the Python URL bolt, the Python split sentence bolt, the count bolt, and the report bolt. This is connected with a shuffle grouping of the URL to the tweet spout, another shuffle grouping of the Python URL bolt to the split sentence bolt, the split sentence bolt to the count bolt, and finally the count bolt to the report bolt. Just labeling our components a little nicer, we have the tweet spout, the Python URL bolt, the Python split sentence, the count bolt, and finally the report bolt that connects to Redis and our live visualization. We see that the Python URL bolt actually calls the URL text.py file. And finally, the Python split sentence bolt is calling the split sentence.py file. So notice that if you don't follow the hint in the split sentence bolt to check for empty values, you'll get a runtime error of none type object has no attribute split. What's happening is the URL being passed is going to be empty, but our split sentence bolt is trying to parse it. And so we get a runtime failure here. And to fix that, we'll simply go and add a check for empty values. And so here, following the hint, we simply check for empty values. Remember that Python is falsy, so if tuple.values at 0 is empty, this will evaluate to false. If it exists, that is true. We set our words, and if words, again checking to make sure that that's not empty, we simply go through and use storm.emit for that word. Finally, in part 6, update your topology to visualize URL words parsed using a Python bolt. Again, running Maven package, and submit as usual. And finally, we see our word cloud updating. So great job on lesson 3, stage 2. Remember that your code will now match lesson 3, stage 3 if you ran into any issues. Great job.